Hi, I'm Rupert. I'm a CG Soup. This is a demo of the lighting and rendering systems that I've set up for a few projects. These systems allow the lighters to light many more shots and render many more shots than they otherwise would be able to if they only had a traditional pipeline. Everything I'm about to show you uses an application called Gaffer, but this stuff can be built with various applications, and people have built this stuff with various applications. All of the big studios will have at least some of these features in their pipeline, and some of them will have the whole lot. The first project I'm going to show you is Messi Goes to Okido Season 3, which was for Doodle Productions. This is the demo scene. This was a 26 episode children's TV show. Over 3,000 shots in total. The first thing to show you is the context system. The idea of a context system is that you tell the application the shot that you're going to work on, and then all of your file paths and your frame range and potentially even the FPS or the color space that's associated with that shot, that will get set automatically. So that speeds up the workflow and it reduces errors. So every studio has got some sort of context system. In this case, we have some shot picker nodes here to tell the application what I'm working on. This info box here shows you the current context, that's episode, sequence, and shot. And then I can change to a different context up here, that's episode, sequence, and shot. And now I'm on a different shot. It will have set the frame range and all of the output paths. I've also got a quick shot picker here, which allows me to just quickly switch between shots within a sequence, which is quite a common thing to be doing in practice. And as you'll see, it's also loading the geometry for the shot that I've got set, and that's because of these loader nodes here. I've got a camera loader that will load the camera for whichever shot is set, and a layout loader. The layout loader will load the environment essentially for whichever shot is set. Now every single shot has a completely independent environment. It's a USD file. That USD file only contains references to other files, to the assets and transforms. So while there is a layout, or while there is an environment, an independent environment for every single shot, the actual file overhead of that is very small because there isn't geometry in that file, it's just references and transforms and overrides. So for example, if I change to a shot that's got some trees in it, let's hopefully find one. Okay, yeah, so in this example, this tree, that might be in thousands of shots literally, but it only actually needs to exist on disk once. Yeah, and then we have the animation loader node. So if I have a look through the perspective camera, then I can actually focus on the animation data, and we can see here is the animation data for this shot. But if I switch to a different shot, then we have different animation data. Like I say, it loads the animation data for the shot that's set, for the context. There were some other loaders that we used in production. We had an audio loader that would load the sound for that particular shot. Texture loader would load textures that was used for assets. And a fur loader, the main character in this show had a Yeti fur system, so we had a node to load that fur system into the system, and we also had a lookdev loader that I'll show you shortly. So I've switched shots in order to demonstrate the lookdev stuff. When I say lookdev, I'm referring to the shader networks and the assignments and the textures that give the assets their look. So it's the materials essentially. In a traditional pipeline, you would just have the shading networks or the materials assigned to the assets all of the time. So you consider the materials to be a sort of integral part of the assets. That's actually not very desirable because you want to be able to switch out the look devs, and you also want to have maximum compatibility between versions of look devs and versions of assets. And if you have the look devs already assigned to the assets and part of the assets, then that creates a kind of dependency mess sometimes that can be quite difficult to deal with. Yeah, so none of the geometry here has any look devs at all. There's no shaders assigned to anything. And the first thing I do is actually to assign a catch-all look dev. So this is just a clay shader that just gets assigned to everything. This character here is called Felix. I'll show you what the clay shader looks like. We just look at this is the interactive render. Let's go play on that. So here is the shot rendered just with the catch-all, and like I say, this guy's called Felix, so I will import his look dev. So I should just do file import look devs character Felix. Here is Felix look dev. So this node doesn't contain any geometry. It's just the shading networks and the shading assignment rules. So if I drop that into the tree, then we get Felix with his look dev on him now. And because this doesn't contain any geometry, it's very quick to switch it out and to load it. So I've created an alternative Felix here, and you saw how quick that was to change. And as a sort of demo of the sort of thing you do, I've promoted a hair color slider. So if I want his hair to be green or blue or pink, then it can very easily be changed. Just to carry on the sort of demo in a bit more of a fun way, I've created a metal version of Felix here. So there he is in sort of gold and stainless steel maybe. And I've promoted a sort of skin material shader with a sort of fun green glow option. So if we want Felix to have green glowing skin for some reason, then that can easily be done. Yeah, so in production you wouldn't want to be manually loading the look dev for each asset. That would take a long time. So we have this look dev loader that I think I mentioned earlier. So if I drop that into the tree, and this has got a button, if I click the button it will find all of the assets in the scene, load their look devs, and there we have it. Now we've got all of the assets have now got their look devs, and this is considerably easier than what you might have to do in a traditional pipeline. Assigning look devs to large number of assets can be incredibly painful, so to just be able to do it by dropping a node in is quite an advantage. On to lighting. So this is the light rig that's being used to render this. It's very simple. We just have a skydome light, which is for the sort of fill from the sky, and then we have a distant light that represents the sun. That gives you this sun direction. In production, we used more complicated light rigs, especially for interiors. Interiors always end up being more complicated light rigs than exteriors. I'm going to switch to a different a different project now to mix it up a bit. So here we have the Settlers project. This was a live action film set on Mars. The post-production for this was done in automatic VFX in Shoreditch, London. And the film featured this robot character who was called Steve. I can show you some plates. So they built a puppet for Steve, and in some shots he was like a prop. But in many shots he needed to do things that the puppet couldn't easily be rigged up to do, so we had a digi-double of him. And this is the lighting for those shots. So it's similar to the Okide project in that we've got loaders at the top, a camera loader, animation loader, environment loader, and because it's a VFX project, we have a plate loader. So this node will just load the 2D plate for whatever shot we have selected. We load the look dev onto Steve and set up a bunch of camera settings. And here we have a projection setup. So this projects the plate for whatever shot is set onto the geometry for that shot. So the easiest way to show that in action is if I switch to viewport rendering. And here you can go. So the idea here, we only actually render Steve himself, but in order to get light bouncing up naturally from the ground, then projecting the plate over the environment gives us that, gets like these little nice bits here. And so maybe I can switch to a different shot. And I'll just show you through the perspective view what that sort of projection looks like. Kind of slightly odd. But this setup projecting makes it quite easy to understand how well the lighting is working as well. But the main goal is to get correct reflections on these different metal parts and sort of the correct bounce light coming up underneath it. So I'll go back to OpenGL so that my computer doesn't melt. And this is showing the lighting. So we have a global light rig here, which is kind of accurate, approximately accurate for most of the exterior shots. All of these backdrops here represent the lighting for different sequences, or in some case maybe specific shots. So if I focus down here, and maybe I'll actually set the interactive render, well, this is the viewport renderer going again. So you can see the path that is being taken by this lighting. So this is on sequence 66. So here's the lighting. So it's taking the global lights and then they're being tweaked by this sequence. So if I change to a different sequence, so maybe 83, give the viewport a second to catch up. Yep, so this shot is still using the global and it's switching through here. Now there were some, just to give you an idea what this is doing, this is changing the exposure and the angle of the light and then twisting it around a bit. I can actually focus above to see the lighting prior to those tweaks if we want. So yeah, so that's the default or the global lighting for the shot. And if I go back down here, then I can see it with the overrides for the sequence. Some shots were interior or nighttime, so these light rigs over here are for interior shots and night shots. So I think I've got one of those ready to show you. So this is quite a different looking thing, and you can see that in this case it's not using the global lighting, it's just coming down here. This is quite a dark shot, so I'll just grade up the viewport so you can get an idea. And the projection setup with the plate being projected over the environment is just the same. I can kind of look out and see what's happening. And I can see my light rig, which is obviously quite different from an exterior light rig. So that gives you a pretty clear idea of the setup. The projection setup's the same for every shot, and then this is the lighting. It's a bit messy, and that's because it's a real lighting scene. This was actually my lighting scene. Real production scenes are often significantly more messy than demo scenes. Okay, I'll show you the rest of what's going on here. So we had 3 render layers. Maybe I'm going to switch to a shot where I've already got some renders on disk to demo this. So we've got 3 render layers. This is the master render layer, and this is the shadow render layer. You can see the setups for them here. The shadow, we split the shadow into 3 channels. So there's red, which is the shadow from all the lights, green, which is just the shadow from the sun, and blue, which is an occlusion. And the third render layer was a utility render layer, and that was used by the compositors. Basically, that's anything that the compositors requested. So I'm going to talk about what I call the fire and forget system. On a traditional pipeline, the lighter's workflow is to submit renders to the farm, wait for those renders to finish, and then they will import them into a slap comp scene, maybe using Nuke. They will slap comp them to make them representative of how they look, to give context, render that out, and then perhaps convert that to a MOV and upload it to Shotgun or whatever review system is being used. Now that's quite a lot of stuff to do after a render has been submitted. So in this case, we're doing all that, but all of that stuff happens as part of the submission. So all of that happens on the farm along with the main render. So we've got these red nodes here are task nodes. So this is a task that renders the master layer, a task that renders the shadow layer. Now, once those are rendered, and in this case they're already rendered, we can read them in. So this is actually EXR files reading off disk. So we've got our master and we've got our shadow, and then those get merged over the plate to give us the slap comp. So these are 2D nodes or image nodes like you would have in Nuke, and they get piped into an image writer, which is equivalent to a write node in Nuke, and that is a task as well. So the sort of logical flow on the render farm is that the 2 or the 3 render layers get rendered, the slap comp then gets rendered out, then we have a make MOVs task that will create a H.264, and finally we have a Shotgun publish task which will push all of that data to Shotgun so it's ready for review and ready to be picked up by the compositors. So like I say, all of that happens on the farm. The lighter only needs to submit once for the shot, and then, like I say, a fire and forget system, they don't need to think about it. The job is completed at that point. So I'll demo some of this batch stuff. I'm going to go back to the Okido scene in order to demo the batch stuff because this VFX shot renders quite slowly. So here we are back in the Okido scene. Everything I've shown you so far is great, but it really becomes powerful when you're sending lots of shots to the farm. So I'm going to demo you some of that here. So this first demonstration is single frame multishot. So this is just sending a single frame of each shot in a sequence to the farm. So I'll stick with the current sequence. I'm going to make some changes to make this render faster. So I will disable the look devs for most things, and that should be okay for now. So the path will be set, the output path will be set dependent on the shot, and this node here will render every shot that's in the current sequence. So it's just going to render to my desktop, so I will kick that off and the frames should arrive in here shortly. So we actually did this in production. If I look at local jobs, you can see the jobs queued up there. It might sound a bit weird to just render one frame of every shot, but actually it's a very useful way of getting an overview for the status of an episode. So in production we would be able to do this for a whole episode with full quality, and because it's rendering on the farm it would very quickly, so you can see how long did that take, a few seconds, and then I can look through and see all of the different shots. I'm only looking at a frame for each shot, but that's often enough to see if there's any problems. Okay, so the next demo I have is rendering a specific shot, But in this this is rendering the whole shot, but it's actually rendering it on tens, and it's also sort of demonstrating a render layer setup if that was what you wanted to use. So I will also kick that off. And if we go back to renders, then that should come there. And this is also demonstrating the auto MOV creation. So single shot render layers. So this is the shot. I'm not sure if I've picked a particularly good shot, but it will render a character render layer. It's rendering EXRs, and it's rendering them on tens, so it's only rendering one shot in 10. Once it's finished the characters, then it will do the same thing for the environment. And so if we have a look here, then it's slightly different to the other one. We've got a wedge node that will render all the different render layers. And then once those are rendered, this is the slap comp. So I know that the character render layer should already be done. There's our character layer. With any luck, the environment will already be done. Maybe I'll go to the first frame. So yeah, there's our environment for the first frame, and then we're merging those over each other. We're also doing a bit of burn in, so these nodes here are putting this extra text on, and then that will get exported out as a MOV file by this node. So hopefully that won't take too long. I can have a look at the job and see. So this is the actual job that's running. I think it's still rendering environment. Let's see. I've actually picked quite a long shot. So hopefully, how many frames have we got? 158. That should be the last one. So now it should create the MOV file. It says it's finished. Okay, so here's our MOV. So yeah, rendering on tens like this, it's a bit like the single frame, except gives you much more information, and this file can also be passed to edit. Obviously in production we would render this with all the normal shaders on and probably high quality, because we would have the advantage of having a render farm. Okay, this last example is multi-shot, so we're going to render every shot in this list here, so that's 12 shots, and every shot we're going to render on tens, and then I'll just kick that off now. So dispatch. So there's the job. So every shot will render on tens. It will get encoded into a MP4 playable, and all of those playables will then get combined into a edit file. So this is the multi-shot file. So we've done the first shot already by the looks of it. So if I have a look in here, yeah, so there's our frames for the first shot. The second shot's already come out. Since it's 12 shots, I will go and make a cup of tea or something, and see you in a second. So there we go, that's finished. So that took just over 4 minutes, and we've rendered 12 shots. We've got the EXRs, they are rendered on tens, and we should have, yeah, so here's our edit. So we would do this for whole episodes in production. We would obviously do it high quality with all of the look devs, because we had the benefit of a render farm. But this would allow us to very quickly see what an episode was looking like, what the lighting was like. We could generally approve the lighting like this, so we could render a whole episode maybe in a couple of hours, or maybe even an hour. One click, render a whole episode, get to see what it looks like. That's quite powerful. And once it's approved, we could obviously change the settings to production and send to the farm for final. Okay, I think that's all I've got to show you.